Hi guys, welcome to chapter 5. We're only going to cover section A of chapter 5 because the rest of the chapter is stuff that we're going to cover through 8th grade Bible study. Okay, so just section A for chapter 5. We're going to combine it with chapter 6 for the test. Anyway, we're continuing to look at the earth around us and just basically observe what we see. Okay. And what we see is that the rock layer, or the rock of the Earth's crust is seen in layers. Okay, those layers are called strata. Plural, stratum would be a single layer. This is another picture from Utah this summer, and you can very clearly see, these even horizontal rock layers that go. Kind of follows along with the idea of that sedimentation tube I showed you, and after the flood, things settling out in order. Okay. Secular scientists refer to this as the geologic column, and it's a model of these strata, and they use that to basically document history. Okay. They use this thing known as radiometric dating to help age the layers. There's some question whether radiometric dating is super reliable. It relies on this thing known as radioactive decay of atoms, and different elements have different decay rates. And so they test the elements in the layers, and then based on that, they make a guess at how old the rock layers are. Okay. They also rely on this principle of superposition, stating that the older layers are down on the bottom and the newer layers are up on the top. Okay. The thing is that they make a lot of assumptions. These secular scientists make a lot of assumptions in their dating process. They also rely on fossils to help date things. Okay, a fossil, first of all, is just the remains of living things. Okay, in order for something to be fossilized, though, it needed to have rapidly been buried, like in a giant flood. The age of the rock is also sometimes determined based on the age of the fossil. Okay, but the age of the fossil is based on this idea of the Earth being 4.5 billion years old. It totally follows the theory of evolution, with these lower level creatures down here and then mammals seen up towards the top, which follows that kind of pattern of evolution. So if you're using the presence of fossils and the age of fossils based on a theory, evolution, to then assume the age of some of the rock layers, that's just too many assumptions. Okay. Now, according to creation, according to the flood, we believe that all of these animals were not only created at the same time, but also fossilized at the same time. It's also a theory. It's just one that I happen to believe in. Okay. That stratification of those rocks, we don't see a lot of consistency, though. Nowhere on the Earth do we see all of the layers that exist in one location. We see some places, some in the other, and sometimes the layers are out of order. It doesn't follow this specific pattern very well. Honestly, I'm not sure what that says about the flood, like how the flood fits into that. But it is some inconsistency based on this old Earth model right here. Okay. All right, so let's get back into tectonics. We talked about this a little bit. Tectonics are the study of the Earth shaping processes. Okay. Geology kind of is too, but tectonics is more about the actual movement of the Earth that causes different things to be shaped differently. Okay. So these tectonic plates are pieces of the Earth's crust. Remember the hard-boiled egg kind of idea that I told you about? If we were to take the Earth and crack it, crack the shell around it, it would be like that hard-boiled egg. So this map right here, let me change colors. Here we go. So this map right here shows the tectonic plates. I'd like you to pause the video for a minute and just kind of look at it. Here is the United States. So there is North America. Okay. So this was known as the North American plate. Okay. This boundary, so a plate boundary is a separation between the two plates. It actually cuts down along the West Coast. This is why California gets so many earthquakes. Next chapter, we're going to talk about that some more. Okay. Each of the continents, so the continents themselves are not plates. You can see the continent of Africa right here is on this huge plate right there. It kind of follows the same shape roughly. Here's Australia. It's on this much bigger plate. Okay. Europe, okay, Europe and Asia, sorry, specifically Asia. Here's Asia. It is actually split, okay? It actually has a plate boundary that goes right through it. Most of the other continents are kind of on their own. India is another one that is actually split off from Asia and the Eurasian plate up there. That follows the idea of Pangaea, okay, that India was originally down here somewhere and moved up there, okay? So remember, Pangaea is that idea of this large supercontinent at one point in the past, maybe the not so distant past if you're a creationist. This idea was first suggested by a scientist named Alfred Wagner. And they kind of thought he was crazy at first, but he kind of kept promoting this idea. And it does fit along with the flood idea. He also talked about this thing known as the continental drift theory. He thought that the continents were moving incredibly slowly. Based on the plates moving, the continents were moving towards each other or away from each other incredibly slowly, which is where one of the things that required that old Earth idea, okay? The plates are moving because of this thing known as seafloor spreading, okay? So seafloor spreading occurs at this mid-ocean ridge. So we've got these kind of mountain ranges under the ocean, and there's a lot of volcanic activity, and it's literally like these mountain peaks under the ocean, okay? Magma, which is this molten material from the mantle, pushes its way up through that mid-ocean ridge, okay? And as that material is coming up, it's pushing out to the sides. So this new sea floor spreads. That's seafloor spreading, okay? So the crust is actually being pushed away from each other at that point. It doesn't open up this giant chasm or anything because there's new rock forming. So as the magma comes up, it's cooling and it's re-solidifying. So there's new crust forming and pushing off to either side at that mid-ocean ridge, okay? There's the definition of magma for you. Well, what we see, because if this was the only thing that was happening, we would see the continents getting farther and farther and farther away wherever there was seafloor spreading happening and maybe crashing into each other again, okay? But we don't see that because we also have this process known as subduction that occurs. So now we've got this trench, okay? This is a little deeper part that usually happens closer to the coastlines. And subduction occurs, okay? So as the rock cools down, it's actually getting more dense. And so it's going to push under another plate, okay? So we have a piece of continental crust over here. And then we've got some of this oceanic crust. As the seafloor spreads, that crust cools. And so it's actually going to hit, this is a boundary. This is where it comes up to another plate. But it's going to sink back down. It's going to go underneath that continental crust. And eventually it's going to heat back up and turn into magma again. And so what we wind up with are these giant convection currents underground in the mantle, okay? Things heat up, they rise, they cool down, they sink. That's convention, basically, okay? So that's seafloor spreading and subduction happening, okay? So again, here's an amazing drawing here. We've got these mid-ocean ridges. They're like these little mountain ranges. The magma comes up. It's not necessarily spewing out as lava, although that does happen under the ocean, okay? As it rises, it cools, though, and so it forms new ocean crust, which pushes in opposite directions, makes the seafloor spread. And there's a lot of evidence for this. This is happening. This is occurring, okay? This is not a secular idea. This is what we observe, okay? As the crust keeps moving, and as it's up there, you know, you've got water above it. You've got the ocean above it. It's cooling, okay? Well, here's the coastline, okay? Here's the continent. There's the beach, okay? This crust is going to move down under this plate right here. So this is a different section. This drawing is amazing. I'm so happy for you guys to have this. As it gets cooler, it gets more dense and it sinks back down, okay? It goes under this plate right here. This happens at a trench, a deep ocean trench, and it's known as subduction. This is a mid-ocean ridge, okay, kind of like a mountain range. It's really hard to draw or write on this, okay? That happens out in the ocean, and that is seafloor spreading. So this process is seafloor spreading. This process is subduction. And I'll show you some videos on this and draw it for you live in class, okay? That's all I got for you guys. Talk to you guys later.